In this episode, we're going to look at how to configure DHCP version 4. I'll show you how to do it, and we'll talk about it along the way. A dedicated DHCP server is scalable and relatively easy to manage, but it can be costly to have one at every location in our network. A router can be configured to provide DHCP services without the need for a dedicated server. As a technician for our company, we've been assigned the task of configuring routers as DHCP servers. We will also be required to configure the edge router as a DHCP client so that it receives an IP address from our ISP. We'll be discussing configuring a router as a DHCP server, configuring DHCP relay, configuring a router as a DHCP client, and then finally verifying DHCP and connectivity. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Configure DHCP version 4. I got the Packet Tracer Lab open up here. On the left side, I have our work area where we have our topology and we can do all of our configurations and verifications that we've done everything correctly. On the right side, we have our instructions in that Packet Tracer activity window. We have our addressing table here at the top. We have all of our devices, the interfaces, what IP addresses. A couple things to note here is on R2, on gig 01, we are getting our IP address from a DHCP server. We're going to have to go through and configure that. Also, down here on PC 1 and 2, we are getting all of our IP addressing information from a DHCP server. So we're going to have to make sure we have that set up correctly. Here's our objectives. Configure the router as a server, configure a DHCP relay, configure the router as a client, and then verify that we have DHCP and connectivity through our entire network. Here's our scenario. We have a dedicated DHCP server. Scalable, reliable, easy to manage, but it can be costly. But we can do a Cisco router to provide DHCP services without the need for the dedicated server. So it's an easy solution. In a true production environment, normally you wouldn't configure it on a DHCP server, but if you need to do something quick or in a lab setting or in a testing environment, this works great. You've been asked to assign or set up a Cisco router as a DHCP server, and that's what we'll do here. Down here, part 1, configure a router as a DHCP server. First one we're going to do is step 1, configure the excluded IP addresses. Addresses that have been statically assigned to the devices or that will be in the future must be excluded from the DHCP pools to avoid errors associated with duplicated IP addresses. In this case, IP addresses of R1 and R3 interfaces, LAN interfaces, must be excluded. In addition, 9 other addresses are excluded for static assignment to other addresses. And what that means here is the LAN IP address and then additional 9 addresses. So a total of 10. 2A here, configure R2 to exclude the first 10 addresses from the R1 LAN. Now, once again, R2 is going to be our DHCP server. So that's where we're going to set up our pools. That's where we're going to do all our configurations, including the exclude statements. Go into R2 and configure it. Once again, I make my window a little bit bigger so that way it displays and formats the text correctly. We can log in. There's no password set up on here, so we can just hit enter, then type enable to get into global configuration mode. Now, to do the exclusion of IP addresses, we need to be in global configuration mode. So go ahead and type config T, sorry. And then the command here to exclude those addresses, we start off with IP because this is a function of IP. And we are in the DHCP service, so IP DHCP. Then we say excluded dash address And then we say, what addresses are we going to exclude? We're going to exclude the first 10 addresses for the R1 LAN. If we look up here, the R1 LAN is the 192.168.10/24 network. So we're going to exclude these first 10, including our default gateway, which is this address right here. And so what we have to put in now, after we put in IP space DHCP space excluded address, is the addresses, the start address and the end address for the range of addresses we're excluding. So 192.168.10.1 is the first one, and then we're excluding the first 10. So that's 1 through 10. And now we put the ending IP address, 192.168.10.10. Got to make sure I put a space in there between the two IP addresses, otherwise it'll give me an error. And we go ahead and hit enter. And as a Cisco operating system tradition goes, no news is good news. If I would have had a typo, if I would have did something wrong or missing an option, it would have let me know with some sort of message. But if I did everything correctly, no news is good news. So I did that command fine. We also need to then look at excluding on R2 the first 10 addresses from the R3 LAN. Here's the address for the R3 LAN. This is the first address, so we need to do the first 10 addresses. Once again, we're going to put the server, and we're going to put multiple pools on R2, so we can exclude these addresses also. IP space DHCP, because it's part of the DHCP service, exclude id address. And then 192.168.30, that third octet is different. First address is .1. Now we put in the last address, 192.168.30.10. That will exclude those first 10 addresses on that .30 network. Step 1 is done. On to step 2. Step 2, create a DHCP pool on R2 for the R1 LAN. Now, to create that DHCP pool, what we do is we name it. We put that in there. If that pool isn't created for the name we're putting in there, R1-LAN, all capital letters, once again, it is case sensitive. When we put that in there, if it's not created, it'll create it at that point in time. From global configuration, IP, DHCP, because once again, it's part of the DHCP service, we are looking at getting into the pool of capital R1 dash capital L, capital A, capital M, R1 LAN. Once again, if it doesn't exist, it'll create it. If it exists, it'll just put us into it. I go ahead and enter. Notice our prompt has changed. We are now in the DHCP configuration mode. Once we're in there, we can set what we need to. What we're going to do is we're going to set the network address, the default gateway, and the IP address of the DNS server. DNS server is right here. So that's our IP address. We set our default gateway. So on the 192.168.10 network, that is the interface on the router that's on that local network. This is the default gateway address, 192.168.10.1 network. And then our network address is based off of this. So we can pull the first 3 octets because we have a subnet of 3255. So the first 3 octets is our network address, followed by zeros. We can pull all that information right from our addressing table. We are in R1 LAN pool here, so we can go ahead and specify it. Our network, and we start off with a network statement, because that's what we're specifying, is 192.168.10.0, and then we have to put our subnet mask in there, 255.255.255.0. That is our network command. Then we can go ahead and say what our default gateway is. Remember, the default gateway, the way the Cisco iOS calls it, is a default router. You can use default gateway, default router interchangeably. So default dash router, and then put the IP address of that default router in, 192.168.10.1. Now, you don't have to specify the subnet mask because we're connecting into an existing IP address. This IP address exists already. That interface has been set up, and it's there. When we are specifying this network here, we are setting up that network, so we needed to include the subnet mask. If you're setting up something with an IP address or a network address, you have to specify the subnet mask. If you're connecting to an existing IP address, it does not require you to put in the subnet mask. It's a general rule of thumb, and 99 times out of 100, that works. And so here's our default router, our default gateway, 192.168.10.1, exit off of our network. So it needs to be on our network. It's part of this network right here, 192.168.10.0/24. It's part of it, but it's on the router, and that router connects us to other networks. There's three other networks, and ours makes 4 networks connected into there. There's our default router statement. And finally, we can set up our DNS server. DNS-server is what we put in there. And then that address is, we can once again get that from our addressing table, 192.168.20.254. So 192.168.20.254. And once again, we're connecting into an existing IP address. We don't need to put the subnet mask in. That's the 3 pieces of information they asked us to enter. Step 3, create a DHCP pool on R2 for the R3 LAN. Basically what we just did, we're going to go through, create it. We're going to name it R3-LAN. Once again, make sure it's case sensitive. I'm going to go ahead, type exit out here. You could just put in the new pool. Actually, you can't right here. I'm going to type exit, so now we can go ahead, type in IP DHCP pool, and then our new name here is capital R3 dash capital A, we'll start that over. Capital R3 dash capital L, capital A, capital N. It enters into that pool. If that pool does not exist, it creates it. Then we need to put our network address, default gateway, and DNS server into that. Well, we are on the R3 LAN. Here's R3. This is the local area network. And so our network address, if we look at our subnet mask, it's 3255. So the first 3 octets are our network address, 192.168.30. Third octet is different than the R1 LAN, so that makes them different networks. We can go ahead and set that up. Network 192.168.30.0, and because we're setting up this network, we have to specify that subnet mask, 255.255.255.0. Then we look at setting up our default router. Default router is the exit off of our network, which happens to be on the R3 network or R3 router, 192.168.30.10. Default gateway, Cisco refers to it as default router, so it's default dash router, and then we specify that IP address. Once again, we are connecting to an existing IP address, 192.168.30.1. We don't have to put the subnet mask in. And then the last thing they ask us to enter in is that DNS server. Put our DNS server, here's that IP address, 192.168.20.254. And so DNS-server 192.168.20.254. That's the third piece of information they asked. That takes care of this step. We are done with part 1. On to part 2. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Part 2, configure a DHCP relay. Step 1, configure R1 and R3 as a DHCP relay. once again, a DHCP relay takes those broadcasts that discover and forwards it to the DHCP server. PC1 is on this network right here. This network goes up to R1. Broadcasts typically don't get forwarded in there. That's why we have to set the helper address to point to our DHCP server, which is R2. So we're going to set up an IP helper address on R1 that points to the IP address on R2. I'm going to go ahead and click on R1. Make the window a little bit bigger. No password, so I can get in pretty quick. Enable to get into privileged exec mode. Config T for global configuration. Then we need to specify what interface we're connecting into. If we look at our chart, and we're going to set up the R1 helper address first, R1 is on the gig 00 interface. And so we need to set it up on that address because that's where this broadcast is going to get heard, is on this address. So it's on that address that's on this network, the 192.168.10 network. This is the interface that we need to set that helper address up on, which was the gig 00. Once we're in global configuration mode, it's interface G0/0. Now we can go ahead and set up that helper address. That helper address is the IP address of R2. Now, in theory, we could set up any one of these three addresses: gig 00, serial 000, and serial 001. Let's go ahead. Let's pick out one of those addresses. Let's use the 10.1.1.2 address, the helper address. We're in our interface of gig 00, so to put in our helper address, it's IP space helper dash address. And then we picked out the 10.1.1.2 address that we're going to point all traffic to. So anytime it gets a broadcast in here on R1 on this interface, it's going to send it to the one of the IP addresses on R2. And once again, that was 10.1.1.2. We're connecting to an existing one, so we don't need that subnet mask. So we set up the helper address on the LAN interface on R1. Now we're going to go ahead and do the LAN interface on R3. I'm going to go ahead and minimize R1, open up R3. Enable to get into privileged exec mode, config T, global configuration, and then we need to go into the interface that's on the LAN. So we are on LAN our router 3 here. The gig 3 is the one with the 192.168.30 network. If we look here, that's this network right here. That's the one we're going to use. And so this is the interface. Once again, it's gig 00. Go into that interface. So interface gig 0/0. And now we can set our IP helper address. And we'll use the same helper address here. Actually, let's use a different one. Let's use this one, the 10.2.2.2 address. And so our command here is IP space helper dash address. And then the address we're going to use here is 10.2.2.2. Go ahead, put that in. And that takes care of step 1. On to step 2. Configure host to receive IP addressing from DHCP. Configure host PC1 and PC2 to receive their IP addresses from the DHCP server. Then we'll verify it. I'm going to go ahead and minimize R3 right here. Open up PC1. Click on PC1. Go into IP configuration. That's where we're going to specify that. Right here, we can see that it's set to static. So that means we have to go in here and manually type that in, but that's not what we want. We want to have it pull from DHCP. So we're going to choose this radio button of DHCP. And now it's going to say requesting an address. And just that quick, it actually pulled an IP address from our DHCP server. and it has that information. So it's here, but there's a better way to confirm that. So I'm going to close the IP configuration window. If you go up here where it says IP configuration in blue, click the X on the right side of the blue line. We can now open up our command prompt. From our command prompt, we can go in here and type ipconfig. Ipconfig says we have an IP version 4 address of 192.168.10.11. Remember, we excluded 1 to 10, so the first one available is .11. Here's our default gateway. Now, this doesn't give us all the IP address information. If we want to see that, what we can do is we can type in ipconfig and then put a space /all. The /all option gives us all the available information. And so what we can see here is one of the first things I look for is saying we're using a DHCP server. So right here, it says we have a DHCP server. This is our DHCP server. If we go up here, this was the DHCP server. This is an IP address on R2 where our pool is existing. That's where we're on PC1. Our pool, our DHCP server is up here. So our helper address passed that through and we were able to get an IP address correctly that way. In the packet tracer lab, once again, this is a simulation. And so not everything does show up here. If we were on a true Windows installation, we'd also get some other stuff where it'd say DHCP enabled. It would say yes. So it would let you know that DHCP was enabled. It would let you know the lease times, when it got its lease, when it's expiring. It would give you a couple more pieces of information. But because Packet Tracer is a simulation, they don't have every one of the details programmed into the simulation. It doesn't show that. But if you're on a Windows box, it would definitely show us that. Okay, let's go ahead and look at PC2. PC2 right here. I click on PC2, click on IP configuration. Once again, we're on static, so what we're going to do is choose the DHCP option here. Give it a second, and look at that. It got an IP address already. Let's go ahead and close the IP configuration. On the right side of the blue line, I click on the X, open up my command prompt. I'm going to go ahead and type in ipconfig. I spell ipconfig correctly. Here's our information. Here's the IP address we're pulling. Here is our subnet mask, a /24 or 3 octets of ones. And then our default gateway, or as the Cisco iOS calls it, the default router. We were able to get our information there. And that takes care of step 2, where we configured the host for DHCP, and then we verified that they were getting the right IP addresses. On to part 3. Part 3, configure a router as a DHCP client. What we're going to do is configure the router, one of these connections here, specifically the one that goes to our internet, as a DHCP client. It would be this one going out there. If we go up here and look at our table on R2, the gig 01 is the one that we're going to set as a DHCP client. So we have to go into that interface and then set it as a client. Open up R2 here. I'm going to exit out so we get out of the DHCP configuration, but we're still in global configuration, so we can go into our interfaces. Once again, it's interface, and we are going to configure G0/0 as our DHCP client. That command here starts off with IP address because that's what we're dealing with, IP version 4 addresses. And normally this is where, if we were doing a manual address, we'd go ahead and type our IP address followed by our subnet. But here we're activating the client portion. All we have to do is type in DHCP, and that activates that client. That's all we have to do. And once again, anytime you do anything with an interface, always make sure it's activated. So go ahead and type no shutdown. Activates the interface. Exit out, exit out. Now what we're going to do is it tells us to use the fast forward feature to speed up the process. And then use the show IP interface brief command to verify that R2 received an IP address. what I'm going to do is I'm going to go ahead and type in show IP interface brief. See that? And we're working on the gig01 interface. The gig01 interface still says we're unassigned. I did the wrong one. Oh, I typed the wrong one. You guys get to see me troubleshoot and fix my problem. So what I got to do is I got to go back into gig00, set that IP address up correctly to get it to work. Because if I don't do that, we're going to get errors. We won't have connectivity on this segment over here to our DNS server. Woo, you guys get to see it. So we got to go back into global configuration mode, config T. We need to go into interface G0/0. Should have been G0/1. But we got to go in and fix it. Now we can go IP address, and this is where we have to manually set this IP address over here, 192.168.20.1. So 192.168.20.1. And because we're setting that address, we also need to specify the subnet mask, which is 3 255s, 255.255.255.0. Do no shutdown on it. And that's good. Now let's go back in and change G01 to be a DHCP client. So interface G0/1. The command here was IP address, and instead of manually putting in that, typing that address, all we have to do is type DHCP, or if you forget what you're doing, we can put a question mark here. And here it's saying either type in your address or put DHCP to negotiate an IP address via DHCP. DHCP, hit enter, and then we have to activate it. To activate it, we do the no shutdown. Notice the state went up, change went up, exit out, do show IP interface brief. Make sure we spell IP correctly. Oh, can't be in global configuration mode. Let's exit out again. Show IP interface brief. Gig01 is unassigned DHCP. Now that I did that, notice we got a system message. We now have got an assigned IP address 209.165.200.233 with a mask here. And it shows we have a new adjacency. And so what happened is this interface right here, we set the DHCP. Here they have an IP address. Or sorry, they have a DHCP server. We pulled an IP address. This scenario here is, this is your company right here that we're looking at all the way up to this line. And then this is your internet service provider. And so this interface here, you set as DHCP to pull an IP address from your internet service provider to give you that internet connectivity. Now we're going to verify DHCP and our connectivity. I'm going to go ahead and minimize this. Once again, the DHCP server is on R2. I'm going to go ahead and open that up. Actually, that's where we were. And we can do the show IP DHCP binding. And we can see we have two binding. One is on 192.168.10 network. It's a .11. That was this PC1 here. Remember when we showed the information? It was a .11, and this is the MAC address, so it keeps a record. This is where that DORA request came from. So the Discover broadcast went out to here, helper address passed it on. The offer then came back from the DHCP server to this one because it could route it here because it knew the IP address of R1, and then R1 knew what MAC address, so we could send it layer 2 there, and we could complete that DORA process. Same thing happens for that second binding from PC2. it went through there and we were able to get it. And so these are the MAC addresses of PC1, and this is the MAC address of PC2. And that's exactly what they're showing right here. The binding of 10.11 to... A lot of times when you're talking MAC addresses shortly, just using the 4 last hexadecimals are good. So .10.11 goes to 1470. 10.11 goes to 1470. And .30.11 goes to 2535. .30.11 goes to 2535. That's looking good. And then the last thing, verify PC1 and PC2 can now ping each other and all other devices. Okay, PC1, open that up. To ping each other, type in the ping command, 192.168.30.11. We can cheat and see right here, that's that IP address. If we go up the addressing table, all it's going to say is we pulled it from DHCP. We could go into PC2, figure that out. IP address, I kind of remember it, but right here it says what that address should be from our bindings. Go ahead and hit enter. Now, I'm hoping that because it's requesting and timing out, it had to go through the ARP process. Remember, we have to go through the ARP process where we can look and see where the MAC addresses are, what ports, how do we get to that final destination. We learned it once we did all the ARP requests, then the pings worked. If we repeat that command, easy to repeat it. All you have to do is hit up arrow and hit enter. All 4 should work because it's in the ARP cache right now. Then they say, okay, let's ping everything else. Okay, PC1, we're going to go up and ping our DNS server. Here's the IP address of our DNS server. Ping 192.168.20.254. Hopefully it's timing out on the ARP process again. Looks like it works. I'm just going to up arrow, repeat that one more time. All 4 worked. And then the last thing is they gave us a couple servers right here, www.cisco.com. What this is going to test is it going to look up, is it going to do the DNS? Because remember, the helper address also forwards DNS to there, to the server. But we don't even have to do that, because if we type in IP config, we can see that, IP config/all, we can see that our DNS server is 192.168.20.254. So it's going to go to the DNS server, resolve the name, then get the IP address, and then ping www.cisco.com. Let's see if that works. Ping www.cisco.com. Name resolution gets this back. Now we have the IP address. We're pinging the IP address. Hopefully it's going to fail once because it did the ARP request and then it worked. I'm going to go ahead, up arrow, and the first reply works. All 4 of them worked because the DNS cache had the IP address in it already, and the ARP cache already had the MAC address in there for all of our devices. Let's go ahead and just ping that www.publicsite.com and make sure that works. So ping www.publicsite.com. Did the name resolution. Right now it should be doing an ARP process, times out, and then we get our responses. If I repeat that one more time, up arrow, hit enter, all 4 should work. We have connectivity all through our network. That takes care of part 4, step 4. That was Packet Tracer Labs 7.2.10 Configure DHCP version 4. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.